I got my water. I almost finished it. Okay, I'm gonna finish it now. The custodians are singing out in the hall to their music. Hope it's not going to be interfering with this video. You need to focus on this bad, Larry. I don't like this. We're not. People need to tilt up a little bit more. Hang on. How we doing? Does that help? How we doing? Okay, it's better. It's better. Much better. Nice. Now you can see the Mr. Krabs behind me. Yeah, that is Mr. Krabs, by the way, if you've been wondering. SpongeBob. Awesome, SpongeBob. Okay, here we go. Warning. Danger, Will Robinson. Danger. This problem number 2 is the hardest problem of the week. Yeah, it is. It might even be the hardest problem of this unit. And I know what you're saying. You're saying it's problem number 2. It's not supposed to be hard. It's like problem number 6 is supposed to be the hardest. Because we get harder as we go along. It usually is true, but not this time. Problem 2 is the hardest one. It's going to take, it just takes some thinking. And unless I was to go through and do this with you, it's going to be highly doubtful that anybody would figure it out on their own. It's tough. But I'm here for you. I'm here for you. Okay, I'd hold your hand, but that would be awkward and Corona-ish. So no hand holding. But I'm gonna metaphorically hold your hand through this problem, and hopefully at the end you can go back through it and work it, because I will. And work it. Okay, I'm working it right now. But you will have a problem like this. Guarantee you. You will have. I don't waste my time, people. When I do these problems, I don't waste my time. I pick problems that you're going to see, and you're going to see this problem. So let's do it. Okay, here it goes. Starts out innocent. Well, let's see how it goes. Okay, here's a problem. The density of a 2.45 molar solution, molar aqueous solution, aqueous meaning in water, of methanol. So we've got methanol is an alcohol. It's the bad kind of alcohol. I mean, you can't drink it. I mean, some people think all alcohol is bad, but okay. But ethanol is what you consume. Methanol, you consume that, you die. So it's the bad alcohol is dissolved in water. So we've got that dissolved in water, thank you, a solution. It wants to know what the molarity of the solution is. So we're given the molarity. Let's calculate the molarity. The equations are similar, right? It should be straightforward. All right. So here's what we have. 2.45 molar solution. Now, what does that mean? What does that mean? It means that we have 2.45 moles, because that's what molarity is. It's moles per liter. That means that. So I know how many moles I have, and I know how many liters I have, because this tells me that. So it's 2.45 moles per liter. Okay, now it wants us to convert that to molality. Now molality is equal to moles per kilogram. Moles per kilogram. So the moles are the same between the two different units. So it is 2.45 on top for the molality as well. See, starting out pretty easy, right? Yeah, all we need to do, just get kilograms and divide and we're done. That wasn't so bad. What were you telling me that was going to be a hard? Okay, that's the problem. The problem is we need to get kilograms. We have liters. How are we going to do that? Okay, the reason we're going to be able to do that is what I call the gear changer. The gear changer, density. Density is the key. So this problem and the next, density is the key. Because remember what density is equal to? You do. Density equals mass over volume. Ooh, look, it has mass. I did the one finger point. Look, it has mass and volume. So if I have density, I can go to volume or to mass if I have one or the other. So I call it the gear changer. So if I have liters, that's a volume, I can use density to get to mass. Ooh, and that's what we need in this. We need kilograms down here. Okay, all right, so let's see. What were we given? Okay, we were told the density of this solution, of the solution of methanol, is 0.976 grams per milliliter. So my density is 0.976 grams per milliliter. Okay, what else are we given? It does give me the molar mass of the methanol. It tells me the mass of methanol. Now you can just get the mass of methanol. You could do that. We have CH3OH, and you could add those numbers up and you come out with 32. Okay, you can do that, but I'm here for you. I've done it for you, you relax. So if we add all that stuff up, you get 32. That's the mass of the methanol. Okay, now, you ready? This is the density of the methanol solution. That's going to equal mass over volume. With me? That's the density of this solution. Now this solution is a 1 liter volume solution because that's the definition of molarity. It's that many moles per liter. So I have a liter. If I have a liter of this solution, then, okay, that would be my volume, 1 liter of the solution. So I'm going to put a liter down. Now a liter, be careful here, a liter is 1,000 milliliters. So either put a liter here and change this to grams per liter, or leave this as milliliters and take your liter and make it milliliters. You have to have the same units. If I put milliliters here and liters here, those volume units aren't the same. They have to be the same. So I'm going to take the 1 liter of solution and make it 1,000 milliliters to keep the units the same. Okay. So 1,000 milliliters of the solution. This is my moles over liters of solution. This is the density of the solution. This is the volume of the solution. 1 liter is 1,000 milliliters. If I multiply those, I can get the mass of the solution. Mass, I need that. I need the mass because it's going to be kilograms of stuff. I need that. Let's do it. So let's multiply these two. So multiply 0.976 times 1,000 and it gives me the mass of the solution. Okay, that will be mass equals 976. The milliliters will cancel. When I multiply 1,000, the milliliters cancel and I'm left with grams. So the mass is 976 grams. Okay, now here's the thing. Now you might be saying to yourself, well, just make that kilograms, shift it back over, make it kilograms, 0.976 kilograms, put it there, divide and done. Not quite, because remember, I've been saying it, I've been emphasizing it. Solution, solution, solution density, solution volume, solution mass. Some of you getting it? You getting it? Solution mass. This is the mass of the, not solution, the mass of the solvent. Ooh, so I can't put that here because this is the mass of the solution. Now here's what we remember from the last, well, 2 videos ago. Solutions are made up of solutes and solvents. Now what we want down here is kilograms of the solvent. Okay, we want kilograms of the solvent. If I know, and this is mass of solvent, if I know the mass of the solution, and I know the solution is made up of both a solute and a solvent, if I subtract the mass of the solute, you know what that'll leave me? That'll leave me the mass of the solution, which is exactly what I need to put there, divide it into 2.45 and get this problem over with. Ooh. Okay, all right, okay. You see why this is, yeah, starts out looking innocent enough and then it goes into using densities, and then I have to go back and think about what a solution is equal to. And this mass is the total. It's the total mass of the whole solution. It includes the solvent and the solute. And I need the mass of the solvent. So if I take this mass, and that mass is 976, the mass of the solution, and I subtract the mass of the solute, I will have this answer. And that answer will go right there. But I need that. I don't have that. Oh, remember earlier? I said you relax and kick back and enjoy the show. You don't have to look up the molecular mass of the methanol. I did it for you. It was 32. The methanol is being dissolved in the water. So what is the methanol? The methanol would be the solute. Yes, the methanol is the solute. It gets dissolved in water. So if I can calculate the mass of the methanol, put it here, subtract, and get it. How are we going to get the mass of the methanol? Well, we were told early on here the density is 2.45 moles, and this is, remember, the methanol because of the solute. 2.45 moles of methanol. Boom. Any lights coming on? Anything? Or maybe you're just going, God, no. Well, you're going to have to rewatch the video maybe a couple of times. But hopefully, some of you go, well, wait a minute. If that's how many moles of the solute, which is the methanol, and I know how many grams per mole it is, I can get the mass of the methanol. Let's do it. Okay, here's how we're going to do it. Can you see this? Okay. So 2.45 moles of methanol. 2.45 moles. I'll just put big M, big E, and that is the abbreviation for methanol. 2.45 moles of methanol. And so this is moles. Oh, I forgot to put the moles in there. So moles of the methanol goes on the bottom. Okay, moles of methanol. I'm going to grams. Okay, grams. Mole to gram conversion. You got to remember how to do this, people. Mole to gram conversion. How do we do mole to gram? 1 goes next to the mole. And then we look up on the periodic table everything that makes up methanol and add it all together. Well, I already did it for you. It's 32. So put 32 here. If I do this, 2.45 moles of methanol times 32 grams per mole, that's what that is, grams per mole, I'll get how many grams of the methanol, and that will give me how many grams of the solute. Okay, so 2.45 times 32. 78.4. 78.4 grams is the mass of the methanol, which is the solute. The mass of the solute right here, 78.4. Subtract those. Now finally, we get the mass of, oh, this is supposed to be solvent. I wrote it wrong. Did you notice that? Did you notice that? You did? Good. I'm glad you did. Okay, I wrote that wrong. Thank you for noticing, though. And thank you for pointing that out. I appreciate that. So this should be solvent. Maybe that confused some of you. If it did, I apologize. So solution minus solute gives me the mass of solvent. Subtract those two. That's going to be 10, 6, 5, 7. And that's 7, that's 6, that's 9. And that should be 897.6. Okay, let's just verify it. 10, carry the 1, 8. 8 and 8, 16, carry the 1. 9, 7, 16, 17. Carry the 1, 9. Yes, so that is my answer. So the mass of the solvent, that's the water. This is the water. The mass of the water used, 897.6. The solvent's the water, and I need to put that up here. Finally, we get the answer to this problem. 2.45 moles divided by, careful now, one more careful. Oh my God, how many more carefuls? This is going to be in kilograms, and these were in grams. Remember, this mass was in grams, and this mass comes out to be grams, so that's grams. We need kilograms. Boop, boop, boop. 3 places to the left. 0.8976. So I'm going to divide by 0.8976. That's going to give me my answer. It should come out to be, well, not quite 3, but let's see, 2.45 divided by 0.89, 2.73, rounding it to 2.73, and we can check our answers here, 2.73, and yeah, we nailed it. Comes out to be 2.73. Now listen, that one, don't get discouraged, people. That's a hard problem because of, and it started out so simple. We're just converting molarity to molality, right? How difficult can it be? I mean, they have the same top part. We just have to get the bottom part done. Getting the bottom part done took some work. We had to use the density equation to shift from volume to mass. And then from there, we had to use mass of solution minus mass of solute and calculate the mass of, so we had to do a mass to mole to mass conversion. Whoa, there's a lot of chemistry there. You will see a problem like this on the exam, absolutely. I'm just going to change the numbers. So you want to have this. Don't, and you could just say, I'm not going to do that problem, forget it. Okay, well that's going to be losing 6 points. You don't want to do that. So you want to also not have to go through this video. It's a 15-minute video already. You don't want to go through this video when you only have 3 hours to do all the problems. So have it written down so you don't have to go through it. Maybe write down how to do it, what I did, write it down, or make sure you know how to do it. I will give you one like this, I promise. Now the next problem is problem number 3. I'm going to go to the next video for that one because this is going on too long. Problem 3 is another figuring out molarity. But since we've dragged you through the mud on this problem, hopefully the next problem won't quite be as bad. Okay, fingers crossed on that. Okay, see you soon.